Okay, today we're going through how to find an equivalent fraction to a decimal and an equivalent decimal to a fraction. And we've already talked about how decimals and fractions have equivalents because they both represent parts of wholes. We've also talked about how they're different because decimals have to have a base 10 part to a whole, and a fraction, the whole can be divided into any number of parts. So our first step to changing a decimal to a fraction was to read the decimal in word form. Then we remembered that our decimal place value helps with our denominator of the fraction because the denominator to the fraction tells me how many parts are in the whole. And the decimal place value name at the end of the decimal word form also tells me how many parts are in the whole. So the big idea we want to remember is to write it like you hear it. So we've already worked a couple of examples together. So let's go to example number 2. Example 2, I'm going to read aloud as a decimal in word form, and that would be 9 and 8/10. And when I write it like 9 and 8/10, I'm going to go ahead and keep the whole number part the same. So this is 9, and then I would write 8/10 exactly like I hear it. So I hear tenths as the place value name, so that's going to be my denominator, and there's 8 of these 10 parts, so that would be 8/10. Now 8/10 is not in simplest form because 8 and 10 have a common factor, so since 8 and 10 are both divisible by 2, I'm going to simplify that to 9 and 4/5 for my final answer. So let's try another one. Remember that decimal place value name is telling me how many pieces are in the whole. So this time I'm going to read this decimal number out loud. So this is my tenths, hundredths, thousandths place. So this would be 635,000. So that's 635 parts out of 1,000 parts. That decimal place value name tells me my denominator is 1,000. And then I need to simplify 635 over 1,000. They are both divisible by 5. So that would simplify to 127 over 200, and that is in simplest form. All right, so let's go and look at changing fractions to decimals. So we've already talked a little bit today about converting a fraction to a decimal. Our biggest rule we want to remember is that we're going to divide. This fraction bar actually means the operation to divide. So I'm going to divide here 3 divided by 5. And sometimes it's kind of tricky to remember which one is your dividend and which one is your divisor. So you can always remember that the top dog goes in the house. So that means that the number on top, my numerator, goes inside that division house. The numerator will always be your dividend and the denominator will be your divisor. So let's try a couple of these. We have to remember our dividing with decimals rules when we do this. Okay, so 2/3, I'm going to put 2 inside the house and divide it by 3. 3 doesn't go into 2, so I need to add a decimal and a 0. Now I haven't changed the value of my dividend. My dividend is still 2, but it gives me another digit, 0, to work with. So I'm going to bring that decimal straight up into my quotient. I'm going to remember all of those rules about dividing with decimals, and 3 goes into 2 0 times, and I want to make sure and hold that ones place with that 0. Remember, when you divide with decimals, it's really important to keep everything lined up so that you don't make mistakes with place value. So 3 goes into 20 then, 6 times. So 6 times 3 is 18. Subtract, and I have a 2 again. 3 doesn't go into 2 again. I need something to bring down, so I'm going to add a 0 and bring it down, and 3 goes into 26 times. 3 times 6 is 18. Remember, our class rule is to divide to the thousandths place, and you might already be able to tell what's happening. So even though I'm not completely finished, it doesn't look like my division will ever stop. And we call this decimal a repeating decimal. So we're going to put 0 and 6/10 with the bar above the 6 to show that that bar repeats. Now, if you would have put 0.666 as your answer, I would also consider that a good answer. But if you notice that it repeats, use that repeating bar. So remember, we call this decimal up here 6/10 a terminating decimal because it has a stopping point. We call this 0.6 repeating a repeating decimal because it doesn't stop. And let's do the last one. This last one has a whole number 6. The 6 is going to remain the same as a decimal, so I can go ahead and put 6 and a decimal point because I know that whole number will remain the same. Now I just have to find the equivalent decimal to that fraction and tack it on. Okay? So again, my top dog is 1. The top dog goes in the house. The numerator is the one that turns into my dividend. I'm going to put it on the inside of the house. The 12 is my divisor. And I'm ready to divide. So I can't put 12 into 1, so I have to add a decimal and a 0. Uh-oh, can I put 12 into 10? So it goes in there 0 times. I add a 0. 12 goes into 100. How many times? 8. And 12 times 8 then is 96. Add another 0. Remember, I want to divide out to that thousandth place. 12 goes into 40 3 times, and 3 times 12 is 36. Subtract, I get a 4, and you might be able to tell, even though we can stop at the thousandth place and give this as our final answer, I could keep going, and you can tell that if I add a 0, that 3 is going to repeat. Okay, so then I have to remember that I have a 6 in the ones place. I was just finding the equivalent to 1/12 over here. So now I want to take this decimal and tack it onto the 6 holes I already have. So now I have 6 and 83 thousandths. And since I know that 3 is going to repeat, I'm going to go ahead and put a repeating bar above the 3. But if you have 6.083 as your answer, that's acceptable. All right, that's it. Good job.